Okay, good evening, everyone. Welcome to Google Developers Space channel. And thank you for tuning in to the live stream tonight. I'm Lawrence from the Google Developer Relations team, looking after our developer and startup community in the Southeast Asia region. So once again, a big hello to all our friends watching this session on our YouTube channel. Yeah, thank you for joining Lakopi tonight. We hope everyone is safe and well wherever you are. And do leave a comment in the live chat and let us know where you're tuning in from. Okay, so before we begin our presentations, let me briefly introduce who we are and what we do. Google Developers Space is a home for developers and startups from around the region to learn, connect, engage, and be inspired. We want to empower and connect the community to our people, programs, network, and technologies. And for Lakopi at Developer Space, it is a monthly open mic event for developer community to learn, connect, and be inspired by each other. Every month, a tech theme is selected, and developers will select their topics that they want to share with the community. And this month, our topic is health tech. Now, tonight we have total of three speakers. They will be sharing for about 15 minutes, and you're welcome to submit your questions on our YouTube and Facebook live chat, which we will answer after each speaker. For this Lakopi, we have Aishik Nagar from DementiCare, who will show us how to enable living through caregiving. Wei Ching from Holmusk, she will be sharing more about information extraction of clinician notes. And Anil Kumar from Reach52, he will share about how Reach52 overcomes their challenges with MongoDB and Firebase. Now, let's welcome our first speaker, Aishik Nagar. And for information, Ashik, together with his partner Ritik, came up with a solution to complement caregiving for dementia patients. And they are one of the top three winners of 2021 Solution Challenge. Hi, Ashik.
Hi, Lawrence.
Yeah, okay. So before we go into your presentation, right, could you give us a short introduction about yourself?
Sure. So, good evening, everyone. I'm Aishik. I'm currently a final year student at Nanyang Technological University, where I'm studying electrical and electronics engineering with a specialization in data intelligence and software engineering. So, personally, I really like developing projects which are impactful to society, and that's really what my hobby is, and I love pursuing that.
Yeah. Oh, cool. That's great. And now I'll hand the stage over to you. So yeah, and please share with us more about this dementia care. Yeah.
Sure. So, thank you, Lawrence. Today, I'll be talking about DementiCare, an application to complement caregiving for dementia patients. So, before I dive into the tech part, I would like to give some background and talk about my friend Jack. His father had dementia, and I remember him being completely stressed all the time. He had to shuffle between his 9 to 5 job, taking care of his father, and managing his own personal health. One day, he came to my house quite worried. His father had left for a walk but not returned, and turns out his father had lost the way back home and could not understand how to contact him. We had to search for hours, and this left a deep impact on us. Turns out Jack is not alone. There'll be an estimated 152 million dementia patients by the year 2050. Aging is the strongest known risk factor for dementia, and over 1 in 5 people will be over the age of 65 by 2050. To make matters worse, an estimated 71% of those patients will be in lower income countries, having less access to resources, skills, and finances for caregiving. The exorbitant cost of caregiving only aggravates the situation. Given how widespread dementia is, one would expect the presence of caregiving assistant tools. To give some context, over 50% carers say that their health has suffered due to caregiving responsibilities. And during our talks with patients and their carers, we understood that most patients spend their time on some sort of electronic device. However, there's a tech gap, and no apps exist to actually complement caregiving for these patients. This reduces productivity, accessibility, and efficiency of caregiving while making it tough for non professionals with those skills to nurse their loved ones. Thus came the need for DementiCare, the first two-way interface for caregiving. It provides an immersive and scalable platform for connecting patients and carers from a single application. Now that we have some background about DementiCare and dementia, let's dive into the technical details. So, DementiCare is achieved by creating a feature-rich caregiver interface and a simple yet engaging one for the patient. We used Flutter to develop the application, mainly since it allowed us to develop a cross-platform application with ease. And there were a bunch of useful plugins in Flutter which helped make our development process easier. We used Google Firebase as a cloud platform since integration with Firebase is really a breeze. As with every project, there were a few challenges we ran into while developing DementiCare. Today, I'll be talking about some of these challenges, such as the design considerations we took to provide an engaging interface for the patients and the carers, how we handle the flow of information between the carer and the patient, and how we made use of sensors in the patient's phones for fall detection, proximity sensing, and providing relevant information to their carers. I'll first talk about the design considerations while developing DementiCare. Since we aim to provide a single platform for patients and carers, this means that we need to provide different views for the patients and the carers from our application. During our talk with carers, we realized that the biggest challenge for us would be to make it simplistic and intuitive for the patients so that we don't confuse them while keeping it feature-rich for the carers. So the first challenge for us was to accomplish this from a design standpoint. How do we allow for a single app to provide differentiated experiences for the carer and the patient? The solution was selecting roles during their first sign up. So when users first sign into the application, they're prompted to select a role between the carer and a patient, which is consequently stored in Firebase. Then, based on the role which the user selected, they'll be shown respective views when they open the application. Here I've attached a snippet of code which can complete this functionality. So during the first sign up, you can see a button here which in Flutter, and it will refer to the database and check the patient collection to see if the user is already in the application or not. If not, they're saved as a patient in the patient collection and taken to the home page of the patient. Whenever the patient opens the application next time, they'll directly be shown the patient side of the application. And similarly, something is done for the carer as well. Now that we know about the different views of the carer and the patient, I would like to take some time to demonstrate how the design language is changed for the patient as compared to the carer. So here we can see the personalized dashboards for the carer, and they have access to a large variety of features and services like tracking and geofencing patients, sending urgent notices to them, and accessing their data like large proximity to the device, location and IMU data, and unfinished tasks by the patient. Combined with utility and productivity features like taking notes, reminders, calendar, and a dedicated chatbot, we've tried to provide them with a whole suite of features to take care of patients. So as you can see, Flutter made it really easy for us to develop beautiful UI and animation for the users. Moving on to the patient side, you can see it's relatively much more simplistic and intuitive. We have color-coded buttons, and we generally aim to engage the patient rather than make them do work. So they can look at their family members, play memory games, record memory of everyday lives like a scrapbook, and look at the notices sent by the carer. Most of the heavy work, such as patient activity information, crash detection, fall detection, are done in the background to remove patient input as much as possible. I'll discuss more in the coming sections. So now that we have discussed the different views of the carer and the patient, the question naturally arises as to how we allow the flow of information between the carer and the patient. This becomes especially important since we have to account for the fact that one carer might be handling multiple patients, which is really quite common in shelter homes, and also that one patient might have multiple carers, which is usually the case in family-based caregivers. So how do we allow for the scaling of patients and carers? The solution is that we create a mapping of carer to patient as a collection in Firebase to record the patients under each caregiver. For example, as you can see here, this is an example of a carer document which records the information of the patients under them. This will come under the caregiver to patient mapping, and each document records the addresses and the details of the patients under the carer. We do this in Cloud Firestore on Google Firebase. In a nutshell, we can imagine three broad collections being used for handling our information. The information of the carer is stored as a document in the caregiver collection, while all the patient's data is stored as a document in the patient's collection. The mapping we showed before can be used to send out notices to the required patient or retrieve data from the patient and act as a middleman. For example, we create documents in Firebase to record notices sent by the carer and also to extract the data from each patient. As we have already shown in the screenshots, each carer can now add any patient under them without having to depend on other carers taking care of the patient or requiring a complete overhaul of our database. We simply record a document for each carer and maintain a collection of patients which are under them. Now, whenever a carer needs to access a feature such as tracking the patient, we use the patients registered under them to allow them to select who they want to track. And once a patient has been selected, we can get the details from the Firebase. This piece of code can demonstrate what I'm talking about in more clarity. So this is basically a function to create a record of the patient whenever a caregiver registers one under them. So during the first registration, the carer can simply add the patient's name, their email address, any existing medical conditions, and the SOS contact of the patient. Once the user submits this information, we call the document containing the carer's caregiver patient mapping on Firebase and set this information to register the patient under them. Next, we also add the caregiver's information into the patient's document, and this is separately maintained in the patient's collection. Thus, the patients are created whenever or updated whenever a carer registers them. So as you can see, this chart can easily demonstrate what I'm talking about from a technical standpoint and an implementation standpoint, which is that once this has been done, accessing any patient's information becomes quite easy. For example, the carer enters the track feature, selects any of the patients under them, and once it's selected, we can use the mapping to obtain and render the patient's location from the document. Now, finally, I would also like to talk about some of the heavy work we did in the background, which is quite important because when we were talking to organizations, carers, and patients, we understood that patients get confused very easily. We cannot expect them to manually inform their carers if they get lost, have an accident, or have completed a certain task. So we make use of the sensors in the patient's phone to monitor their activity and trigger SOS calls. Additionally, we also store information about the patient, which we think might be useful for the carer. For example, their battery level and their last proximity to the device. So from a technical implementation standpoint, I would like to discuss how we set this up in our application using some awesome and well-maintained plugins from Flutter. Broadly, we can divide our background processing into proximity sensing, fault detection, and patient monitoring. This chart represents the plugins we use for each of these processes, as well as some dummy code to get us started. So as we can see from our patient's phone, for proximity sensing, we used a plugin called Proximity Plugin. This plugin can actually listen to events whenever the carer is close to the proximity of the phone, and there are actually sensors in phones which can detect this. And once we listen to such an event, we can update it on our Firebase, which can then be consequently pulled into the caregiver's dashboard. Going into fault detection, this is a two-way process where first we use the shake event plugin, which makes use of the sensors inside the patient's phone to listen for any kind of faults or massive shakes of the phone. And we can also trigger the parameters of these and thresholds of these sensors so that we have an accurate detection. And once we actually listen to some event like this, we can use telephony, the plugin, to send an SMS as well as call the patient automatically without the patient's input. Finally, to monitor the patient, we used Flutter background geolocation. This not only allows us to track the patient in the background, but also access to some of their activity details, like whether the patient is walking or on a car, and also if the patient has what the battery level of the patient is, and so on and so forth. So moving forward, we realize that the need for tech-based solutions for caregiving will only increase with time. Thus, we want to take DementiCare forward and make it a useful tool for caring for dementia patients. Our goal is to work with real-world carers, patients, and network with professionals to actually build a product which is useful for society. We want to keep developing, adding new features, and refining the ones we have, and hopefully do something good for society. We are already in talks with some organizations like Alzheimer's Disease Association Singapore, some shelter homes, as well as healthcare organizations to collaborate and obtain feedback about what we have built till now. We recently emerged as winners in the Google Solutions Challenge, and their mentorship actually really helped us take DementiCare to the next level. While there were many more challenges we faced during our implementation, I tried my best to explain the gist of what DementiCare is all about and how we went about solving some of the core challenges we faced. Hopefully, this will be useful to developers and students around the world. And if you'd like to talk more, you can definitely hit me up. It was a pleasure to give a talk at La Kopi, and I hope to work on more such impactful projects in the future.
Wow, thank you, Ashik, for the presentation. Thank you so much. Yeah, so it's time for Q&A now. And if you have
Sure,
any questions, please feel free to actually put them in the live chat section. And then later on, we'll actually go through with you. Yeah. And then while waiting for the questions from the audience, maybe we can go through some questions that we received during the registration. Yeah.
sure.
Okay, the very first question is that was the focus to always develop the Medicare as a business, or were you just focused on making the tech possible when you began? What was your approach to this?
Okay, so I would say that initially we started off as a pet project. It's something that me and my friend wanted to do together because we noticed that this was something which would be useful to people. And as we went about developing it, we started reaching out to organizations and trying to get their feedback on what we have built. And as we went deeper and deeper into the development process, we started to realize that this was actually a project that could make a difference in society. And especially once we got into Google Solutions Challenge and we started receiving mentorship from them, we realized there is definitely potential here. So that is when we started to take things more seriously.
Okay, I see. Okay, so we also have another question. The next question is this: how did you convince user adoption? Could you explain the process and give specific examples about the departments and the group of people you approach and training you had to do?
Okay, so about user adoption, we are currently, in the phase where we are talking to patients, carers, and organizations about how we can make dementia care better. So in that regard, I think the what we actually did was try to build a project or a product which was useful to them, and we were actually presently surprised at how many organizations and how many people were willing to adopt this. So once we started talking about these kind of things, and especially when we started receiving some mentorship from our professors who we approached and going into competitions like Solutions Challenge who provide mentorship to developer projects, this made it even easier for us to target what we wanted to do and have a very concrete approach about it.
Okay, okay, cool. Yeah, so let's see if you have any questions. If not, then maybe we can actually move on to the next speaker. Okay, so thank you, Ashik. Thank you for your time and your presentation. So I'll actually remove it from the stream, and then we'll go to the next speaker. Okay, thanks, Ashik.
Sure,
Thank you so
thank
much for
you.
your time. Okay, now next up we have Wei Ching. For information, Wei Ching is a data scientist at Holmusk, and she's also a graduate from our Women Developers Academy program. So a Developer Academy, right, is actually a fellowship program dedicated to equip women developers with skills, resources, and the support that they need to become a tech speaker. So let's welcome Wei Ching.
Hi
Hi.
everyone, I'm Wei Ching and I'm a data scientist at Holmusk. I'm very interested in seeing how we can use technology and AI to make an impact the lives of people on us. Thank you for having me here today.
Yeah, great. Thanks for sharing. Yeah, it's really good to have you tonight. So I'll just hand the stage over to you. So maybe you can actually tell us what you're doing, with all your this data. Okay, cool.
Hi everyone. Today I'll be sharing with you about what we do at Holmusk regarding information extraction from clinical notes. My name is Ching. Today's content will be split into 3 parts, namely to first share with you more about the motivations behind building this information extraction or IE model. Then I'll show you about the NLP model pipeline, and lastly talk about some of the results and limitations of this model. Firstly, diving into the motivations for developing this IE model. Hospitals face a very high patient readmission rates, and this is costly for both the patients and hospitals. Now, how can we reduce patient readmission rates to improve patient outcomes? This can be done by tapping on a huge database of information called the clinical note. And by extracting information from this clinical note, we're able to do some downstream analytics, such as by predicting the readmission risk of patients. For IE models right now, there are some challenges that we face in building these models. So taking a clinical note as an input to the model, and note that this clinical note is in an unstructured format. We'll use some rule-based and ML models and then output a clinician assessment of the patient in a structured format. And some of these challenges regarding using rule-based and ML models would be that it might not be as exhaustive in nature, given that we have a large domain of text and it's very specific to the clinical domain. These using rule-based techniques might not be the best. Next, we also identify that there are various clinical domains and these domains might be very specific. At Holmusk, we are interested in the behavioral health space, namely the psychiatry notes. And with these psychiatry data, we have even more vocabulary that is very specific to this clinical domain. Lastly, we also have some region-specific information whereby different clinics around the countries might have different ways they do diagnosis on the patients. By using such rule-based and ML models, it might not be very scalable across different clinics and even countries. Thus, this motivated us for building an IE model. This is a sample clinical note that we can see. And what are some of the output information that we desire? We want to identify the various topics and information such as the diagnosis, what's the mental status examination, some prior hospitalization, or even social history information in the clinical note. So to give you an more illustration, we'll see that putting a clinical note through the NLP model, we want to identify the topic. So it can be diagnosis, and then we want to identify the particular label, for example, psychosis. And then there might be some contextual information regarding this label. It can be whether the label is present or not. So that's a negation context. Whether it's a current information or historical information. And lastly, about assertion. So it can be that the information in the clinical note is not associated with the patient. Maybe it's the patient's family members. And thus, we want to add in this contextual information to better understand what's the patient assessment. And to give you some context, the number of labels that we are looking at, it's in this box, 9 topics, 86 mental status examination or MSE labels, and 71 social history labels. Moving on to the NLP pipeline and model training process. The whole model was developed in this way. First, we get our data from the SHAPE database. we develop a set of labels, and then we manually tag these sentences with our developed labels. Then we train the model. So putting in a sentence, we can use either a deep learning model or rule-based model and output some topic labels of this sentence, and then we'll evaluate them on a whole set. And in today's sharing, will focus more on the deep learning model that we use in this process. The deep learning model we use is called BERT, which is very powerful state-of-the-art model. It's able to understand context information very well. And this is because it's being pre-trained on a huge amount of corpus. And this, after building this BERT pre-trained model, we are able to fine-tune it on various NLP tasks without major changes to the model architecture. And this means that we can use the BERT model for many NLP tasks, including information extraction. So with pre-trained models, you might ask, what sort of text was this BERT trained on? It was trained on Wikipedia corpus, and with that, you might also think, what if it's trained on other types of data? And indeed, BERT was trained on various types of data. We have various variants, such as BioBERT and Bioclinical BERT, which was additionally trained on more clinical data sets. And with these many variants, we want to identify which variant would be the most suitable for our use case. What we did was to use the masked language modeling task, where it's sort of a fill in the blank kind of task. Given the sentence with some words masked, we want to identify what are the possible words that were masked. And to evaluate the performance of this MLM training task, we can use the accuracy score. For our use case, what we did was to modify the accuracy slightly to take into context some similar words. So for example, depression and anxiety might have similar meaning and might not be very important in our use case. We just want to identify whether the BERT model is able to understand the information and does not need to predict the exact word. So by making this metric more lenient, we're able to take into account more words. After trying out BERT, BioBERT, and Bioclinical BERT, Bioclinical BERT gave us the best accuracy score, and that's what we are going to use for our model. As for the model architecture, after we put a document through BERT, we are interested in being able to classify the sentences. And this is done by taking the output of the 12th or last encoder of BERT. And then we'll build dense layers by using either the CLS tokens or all the tokens as input to these dense layers. As with all deep learning tasks, we're also interested with the loss calculation. And for our use case, we created a loss that takes into account both the labels and the contextual labels. For the labels itself, we will first take the binary cross entropy loss, and then we'll include some positive sample weighting, meaning that the labels that are present would be weighted more than the labels that were not present. And this is very important because out of, let's say, 86 MSE labels that we have, one sentence might include 2 to 3 labels only, and it's a very sparse data set. So we will need to weight this positive sample more. Then we also take into consideration sample weighting, whereby we want to weigh out the classes that have the least number of sentences. And this is to balance the imbalance in the number of sentences across various labels. Lastly, for the context labels, we also add an additional loss, which is masking, where we want to only count the loss for where a label is present. As for the model training process, what we did was to use the Hugging Face Transformers library. It's a very powerful library which enables us to code both in TensorFlow and PyTorch. Then we used the AWS EC2 instance because it was very difficult to train on CPU, or rather it takes a long time to be able to train BERT model with many hyperparameters. Lastly, we optimize the hyperparameters that we're tuning on the classification layers, and to do it in a more effective way, we look at the Bayesian optimization technique. To evaluate the performance of our models, we use the recall score as the main performance metric. And this was because it's costly to make a wrong diagnosis. We also added a k-fold cross-validation technique when we are training our model. And this is because for the MSE and social history data, we have very small sample sizes across some of the labels. And splitting into 3 data sets, train, validation, and test, would mean that some sets would have very low samples. And what we did was to do a k-fold cross-validation where it's split into 3 data sets and 3 models were trained on each set. Then we'll take the validation for of each set and evaluate to find the performance of our model. For the contextual labels, we also did a separate evaluation technique where we consider the label and the contextual label. For example, when we want to understand the performance of our negation label, we have the targets of whether it's present or absent. And these would be one of the confusion matrix that we created to understand how to calculate the negation scores. And one important thing to note is that there doesn't exist a 0-1 label, because if the label doesn't exist, then we can't have a negation for that label that doesn't exist. Yeah. Moving on to the last part on the results and limitations of our model. This is the best results we have so far, and we are still in the midst of developing various models. So yeah, take this with a pinch of salt, and we hope that we can share with you better results in the future. Some of the limitations that we have while developing these models was the potentiality of the inefficient processing of the model, because this model, BERT model we use is very large, and there are many classification tasks that we're trying to do. So we are trying to predict the topic, the MSE, the social history, and with so many tasks and so many models, adding them up together, it can be quite some time before we are able to predict the results. Next would be that the data set might not be very representative. For us, what we did was to manually label this data set. And because we have many different people labeling it, although they might have undergone some medical training, they might not be labeling some of the sentences the same way. And what we did was to conduct an inter-rater assessment on these clinicians' annotation. And lastly, that there may be some new categories and labels in the current data set that might not appear in other data sets. So this means that by tailoring the list of labels to our current data set, we might miss out on other labels where the data is not present. So this marks the end of my sharing. If you have any questions, feel free to ask me.
Hey, thank you, Wei. Thank you so much. Yeah, wow, it's actually a very technical presentation. Yeah, it's actually really new to me. But I believe that those data scientists who are listening to this live stream, they'll take something back, from your presentation. So audience, don't be shy. If you have any questions, please feel free to actually put them in the live chat section. Okay. Now, for Ching, we definitely have some questions for you from the registration. Okay. Now,
Yes.
maybe let's look at some of the questions. Maybe shall I remove your slide so that you can see the question?
I can see it, don't worry.
Okay, see it. Okay, cool.
For
Great.
us, we
Yep.
use various metrics, including recall precision, but the main metric that we were looking at was the recall score. And this is because we want to be able to know whether the model is predicting the predicted result is true or not, right? And if it's more costly if there's a wrong diagnosis being predicted. That's why we focus on the recall score.
Okay, cool. Yeah, so there's a comment from Leonard, very clear, even from point of view of a non-technical person. Well done. Reaching. Yeah.
Thank
Okay.
you.
Thanks, Leonard. Thanks for the comment. And then well, maybe we have a next question. Yeah. So what accuracy how would predicting the labels help in reducing the readmission rates?
Sure, thank you for your question. I can share with you a slide that I have. So after what we did was to put the notes through the model, and this note represent one visit by the patient to the clinic. And we hope that by identify the various labels present throughout various time points, meaning various clinic visits, we are able to do some modeling techniques that would be able to identify what's the risk of a patient. I hope that answers the question.
Okay, cool. And then we have one last question for you. Yeah. So were there any challenges faced in pre-processing the data in the pipeline prior to breaking them into sentences?
For us, there was not many challenges in that because our data is rather clean. Okay. One thing that I remember is that when we're trying to tag the sentences, basically we need to split the notes into single sentences, right? And when we use existing tokenization techniques like NLTK, it somehow would split various numbers. So for example, in the note, we have like number one, this was the medication, number two was the second medication, and the NLTK would split one and the medication. So it means that it's supposed to belong to a same sentence, but because of what existing techniques that we use, it was split into two sentences. Yeah, so what we did was to do some manual process where we have to stick back the numbers and the associated sentence together, and then we'll unsplit them after it's being tokenized. Yeah, so these are some of the things that we did.
Okay, thank you so much. So hopefully all your answer actually answer those questions, right? Okay. So thank you so much again for the presentation. So I'll move you backstage so that I can actually invite our
Sure,
last speaker
thank
for
you.
tonight. Okay, thanks, Richie. Thank you so much. Okay, so last but not least, let's welcome our last speaker, Anil Kumar. So Anil is the lead Android developer in Reach52. So to give some context, right? Reach52 is a tech social enterprise whose mission is to connect 52% of the world to the health services that they need. Okay, and Anil is one of the driving force to drive this mission. Hi, Anil.
Hi,
Hi, Anil.
hi. Fine, good, very good. How about you?
Thank you for joining and taking your time out to present and to tell us how you overcome the challenges. So could you tell the audience who you are and what you do?
Myself, Anil, actually have working as a senior Android developer in Reach52. I have 10 plus years of experience in Android domain. So I worked in different domains like logistics, e-call, and now I'm presently working in healthcare. And in my 10 years of experience, I implemented around 30 plus applications, and I implemented top applications which is running now in European countries. That is what my brief introduction.
Okay. Yeah. Thanks for sharing. So I'll hand the stage over to you. And if you can, right, maybe you can put your mic nearer, so that it be louder. Okay. Cool. So the stage is yours.
Yeah.
Yeah. And you can actually start your presentation. You can start from the first slide.
Can you see my screen? Hello. Yeah.
Hello. Can you hear me?
Sorry. Yes. 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 Let me share.
Okay. So maybe you can actually start your presentation.
Sure. Sure. Oh, what am I saying? So,
No
hi,
worries. I think
myself
there's
Anil.
some
Yeah.
technical issue. So let's
Yeah.
we'll give you some time to rectify this. There's no problem. Yeah.
No. It is fine. It is fine. Actually, now I shared
Great.
my screen.
Great.
Can you please
Great.
see my screen?
Okay.
Yeah.
Cool. Okay. So
Yeah.
it's time to present. Okay. It's all yours.
Yeah. Thanks for that. Yeah. Actually, I'm from Reach 52. So, what is Reach 52? Actually, in this pandemic period, there are a lot of health issues that is coming. Even if we are influenced with the political or economical way, we are not able to get a proper medicines on time. Because of this, there are a lot of people who are died. We all know these things. So, what we are actually who we are. So basically, Reach 50 is a product-based company. Our main goal is to serve the rural areas with the healthcare. So when we start with any the startup companies, right? So we have to identify the existing problems and how it is causing for the peoples or any kind of things, and what will be the solution for this. Now, same way, Reach 52 was started with the problem identification. So in our whole world, there are 52% of the people they can't able to get a proper healthcare things, and they can't able to reach with the medicines, vaccination, diagnostics. There are many kind of the healthcare things they can't able to reach because of many reasons. One is they were very lack with the internet connectivity. They were not educated with, and they were not connecting with the any like educated peoples. Because of that, this 52% of people they can't able to reach the healthcare healthcare services. So because of this, they can't able to reach the healthcare services in time. So they were committing with the different disabilities, lost opportunities, and they were missing with the communicating with the educated peoples. They were not getting a good health facilities in rural areas. So for this is the cause. So for that, the Reach 52 found a solution to reach the rural areas with the some good healthcare services, how with the offline services. In most of the regions, they were not knowing the internet connectivity, they were not know the smartphones itself. So for them, it is very hard to order the medicines and connect with the doctors. So because of that, Reach 52 targeted with the internal agents. Agents were going to the rural areas. They were connecting to the residents, those who are very uneducated and they don't know the how the healthcare things will work and what will be the reason for the diseases. They were our Reach 52 agents were training them with a health health guidance, and this is how the Reach 52 is working. Uh, So, what is the purpose of Reach 52? The purpose of Reach 52 is we need to provide a healthcare for the 52% of the people, those who are not accessible for the health. So, our vision is the healthcare services we need to provide within a range. Basically, the poor people, they can't able to afford with the huge money to get a healthcare services. In this sense, the vision is we have to serve these healthcare services which is within a affordable prices. That is our main Reach 52 vision is. And where we work, actually we are working in different countries in the world, like Singapore, India, Philippines, Indonesia, Cambodia, Kenya, and UK. And our offices like a hubs. Actually, we are going to the rural areas. We are creating a hubs. Through that hubs, we are uh, training our agents through, and agents were correcting the resident data, and they were guiding with the healthcare diseases. So what will be the cause for the disease? All those things. They were training for the resident rural areas. And how we are promoting our the goal in our rural areas. We are connecting the growth partners. It is like a private sector guys or NGO kind of a things, or any community based organizations. We are contacting them, and we are proposing what is our idea and how Reach 52 healthcare is helping in our rural areas. So through them we are connecting the rural areas, and we are serving our service. How it works is, actually we are recruiting a growth partner, as I told now. So there are a lot of private sectors and NGOs, private and community based organizations. We are connecting them, and basically agents in the sense the healthcare workers in the government hospitals or in a private hospital. There are many ASHA workers will be there. We are connecting them, and we are training them with the our software, and we are equipping with the our platform. So how the platform is, what is the data we need to collect from the resident, those kind of a data we are collecting through the our agents. And scalable services is the sense, actually we need to uh, give a proper instruction to the government or private sector, because there are a lot of terms and conditions will be there. Directly we can't collect the health based information from the rural areas. So through that we are training with the private sectors and organizations, and NGOs, and as well as the government organizations as well. This is how the RH52 is work. Actually, how when it goes to our tech is work is, we have a agents. Our agent, we are creating a one login credentials for them. They were logging into the our RH52 access model. This is our application, RH52 app. They were logging into the our app, and they were creating a resident with their personal details and our health their health issues. And in case if they were undergoing with any medications, so we are collecting their medication data. And finally we are like calculating in case they were suffering from any diseases, we are finding the root cause for that disease, and we are providing medicine for them. So after registering a resident, we can do a vaccination. So actually here insurance, we can provide the insurance policy to them, medication, health log, and the profile information. Profile information in the sense we are using some COBA form of a thing. This like emergency purposes, we are using a COBA forms. Through that COBA forms, we are specific health questionnaires we are asking them. So we are collecting those health related questions from the resident. So then after that we are collecting we are finding the root cause for the diseases. Basically, as I told, the agents for health workers, they know they have little bit knowledge about the health system, so they can immediately provide the medicines to them. So educate this application is not for the end users. The end users, basically they were in a rural area, and they were lack of internet connectivity. They don't know the so smartphones instead. So our agents going to the rural areas, and they were serving the insurance policies, medications, and any kind of the health related services if they needed. Then through our app, agents were providing to the rural areas, rural residents. So basically, when we start with the Reach 52, we have started with the one application called Marketplace application. So now it is deprecated. Now we are come up with the Reach 52 Access app. That is what I explained in a previous slide. So the previous application, it is pointed to the coach base, and we have Kogo forms in that as well, and it is a Firebase. It is included, and it is supporting. There are the two different modules in the previous application. There is a MAMS and CAMS. MAMS is marketplace access managers, and CAMS is community access managers. MAMS, they were just registering the residents, and CAMS, they were providing health related services to the residents. That is what it is happening in the previous application. But due to some reasons, we are combining all MAMS and CAMS in a single app, and now we are coming up with a new and fully modified application now as a Reach52 Access app. Now it is in live, and to implement this app, we are using Kotlin, MongoDB, Coboform, Firebase, and Tornado. So MongoDB realm basically our application should work 100% offline kind of a thing. Because of that, we are using MongoDB realm and Kobo forms in case any immediate situations if we need to add any health related questionnaires. We can't able to deploy, we can't able to modify the our database or our application immediately. So for that purpose, we're using Kobo forms. We can immediately updating into the Kobo toolbar. It is available for the users. And Firebase, we are using to track the orders, and we have a different module called ADB vaccination program. For that vaccination program, we are sending in-app messages where the our vaccination program is conducting, and what is the purpose of vaccination program. Those kind of in-app messages we are sending to the Firebase. And Turnivo, it is a WhatsApp messaging tool. This we are using for an immediate purpose, like in case if the user has found any kind of symptoms, they can directly get whether that symptoms it particularly depends on a particular disease. For example, if I have fever, is it fever related to the COVID, or is it a normal kind of a fever? For that, they have to just enter the options. Like we are giving multiple options to them. If they select any of them, so based on that, we are calculating. Then we are displaying them. Is it like any particular disease, or if there is a normal fever or something? That purpose we are using Turnivo. And actually, in a previous application, we are using say a different logins for the maps and camps. In the new application, we are using a single login for maps and camps. These are like two different applications, like Android application. When it comes to app, we have access and insight and logistic application. Access, what it will do is actually, as I explained you, in case agent or our ASHA health workers doesn't know the what is root cause, or if they are not knowledge about the particular diseases, we are providing some information through the access web applications, so they can our agents can read the blogs. It is from the doctors, or it is from the like any public platforms, or any public blogs. We are pulling the data from the outside, as from the doctors. We are putting into the access web application, so that so agents can go to the information. They may much aware of the disease, or they know much knowledge about the diseases. Those kind of information we are submitting in access. When it comes to insight, so the super admin can able to see the resident who are registered in a particular area. So there are different kind of a search options we are using it, providing an insight web application. When it comes to logistics, actually, when we are ordering for a medicine for a particular resident, so we can able to track. So after ordering a medicine, so once our agents is searching in a local pharmacies, they were taking that medicine, and they can update the status with a pending to the delivery or dispatch it, or it is rejected, some kind of a option status changes. They can do it in a logistics web application. And this is the ADB vaccination program. For now, we are working on this one, ADB vaccination program. And Philippines government, actually, they were waiting for this module. It is very interesting module, actually. In rural areas, there is a lot of healthcare services, and they don't know about this COVID until it become very huge. They were not aware of all those things. Even now, if you go to some rural areas, you tell them this is a COVID, they were not bother about what it is. So for that, actually, we are providing 100% offline kind of a vaccination program with collecting all their records. How it is working is there are three different modules in the ADB vaccine. ADB means Asian Development Bank has initiated this vaccination program. So for them, we are developing this module. Our super admin as creating a vaccination program, and there is a campaign admins over there and vaccination providers, three different modules. Super admins were creating just a program, and our campaign admins, they were adding the which vaccinations which is available for that particular vaccination program. It is not only for the COVID vaccination. There are different kind of vaccines available for the like patient. So those kind of a vaccination programs we are creating it. So the campaign admins, they were adding the vaccines which is available for that particular vaccine. So after that, they were launching that vaccination program. After launching that vaccination program, it is available for the agents in a particular region. For example, if we are launching that vaccination program for the India, for India agents, that vaccination program is available. So they can basically, they were already registered with the resident. Just they need to add those residents to the vaccination program. And again, in this module, there are two different kinds. One is they can, like now it is running like vaccination mandates. No need to pre-register. They can directly come and they can vaccinate. And one is appointment. Take an appointment and go to that particular venue and took a vaccination. Those two modules we are implemented in our ADP vaccination program. The tech challenges actually, there are different kind of a tech challenges we faced while migrating the data from Couchbase to the MongoDB. Basically, the old application which is pointed to the Couchbase, and a new application, new Android application which is pointed to the Mongo realm. So in Mongo realm, actually realm and Mongo, it is totally a combined one. So in case any object it is mismatched or any data type it is mismatched, there is a cause called sync stop. If sync stops, whatever we are doing it offline, it is storing in a middleware, but it won't push back to the Atlas. So those kind of issues where we are going to face in case if you're not migrating data properly. And again, in a new application, we maintained a different architecture and different structure, database structure. So for that, actually, we use Python to migrate our database. And again, the realm sync stop issue. This is like a very major issue. What will happen when initial stage we don't know uh, the cause. And one more disadvantage is Mongo realm is we can validate our schemas up to 1,000 records. After that, in case in a 1,001 record or 1,015th record, in case any data mismatch or any invariant schema it is there, then it is not validating that particular record. That is the one disadvantage is there in a Mongo the schema validation. So to identify that particular record, what is the issue and why it is causing that leads to the realm sync stop issue. For now, we developed some kind of a scripts to validate all the data types, everything. So that is our major issue we faced, and now it is fine. Now it is working fine. And data loss issue. Actually, this is happen when realm sync has stopped. Basically, realm sync is a middleware. It is connecting between the realm and as well as the MongoDB Atlas. If realm sync stops because of any reason like schema mismatch or data validation issue, any kind of a reason, if realm sync stops, we can able to operate our Android application properly. So we can able to see the residents, we can able to add the resident, we can edit it, we can do all the operations, but it won't sync back to the central DB. So this is because of this reason we are going to miss when we restart the realm. So we are going to miss the data which we are already we are added, and it is not synced to the central DB. Those data we are going to miss. So for that, what we did actually, in case we are identifying whether sync is running or not. If it is not running, we are identifying in an app like whether that particular data it is synced or not. If it is not synced, then we are storing in a somewhere in a cache storage, and after restart, we are pushing back that data to the MongoDB Atlas. And auto logout issue actually in a Mongo realm is in a like very initial stage. It is not fully stable yet, but they were implementing fine now. So in our initial stage, automatically the application become a logout. So again, the user need to re-log in again. But our agents in rural area, they can't able to access the internet connectivity. So there they are facing a lot of issues. They can't able to log in and they can't able to profile. So those kind of issues we are facing it for now. So after communicating with the Mongo support team, we got an update. Now it is working fine. So again, Realm instance issue, it is happening in the initial stage. Like, so first thing, when we log in, Realm is creating one instance, and again, in the next time when we reopen the app, we are not generating, or we are not logging again with the HTTP connection. Directly, we are kind of taking the existing instance, and through that instance, we are just moving with the main pages. But this was the issue. It is the Realm is not initiating, so it is stuck in a splash screen. That was the issue we faced earlier, but now we resolved it after connecting with the MongoDB support team, and we updated SDKs. Now it is working fine. Offline login
Hi,
implementation. Offline login
Anil.
implementation.
Sorry to interrupt.
Yes.
I think we're running a little bit short of time. Maybe we can speed up a little bit. Yeah, so that we can actually cover the more technical portion. Yeah, thanks, Anil. Thank you.
Sorry. Sorry for that. Yeah, thanks for that. Sorry, I just escaped it because of that. Yeah, yeah. This is offline insurance. Actually, presently we are facing this issue like offline insurance. There is a terms and condition in a different countries to provide an insurance for a resident. We have to take an OTP verification kind of a thing, or digital signature kind of a thing, signature kind of a thing. But in offline mode, we can't able to send a OTP, and we can't able to like verify the profile. This is what the present issue we are facing, but we are running with some workaround for this one. I think that soon we're going to solve this. My experience with the different applications is actually before coming to the Mongo realm, we manually writing lot of codes, and we are maintaining our own triggers to check whether the particular object is in which mode, whether the particular object is updated or deleted, or new profile is inserted. We are using some time constraint kind of a thing. Through the time constraint, we are getting the data. Those kind of challenges we are faced before coming to the MongoDB or Coach-based DP. These are like my previous applications. I faced this issue in my last company. So now, yeah, there are a lot of things like app performance, battery consumptions, everything. I need to handle it manually. But now, Realm is taking care of everything. Now the main topics for today is application of a Firebase. So Firebase we are using in our application to track our medicines and update the status, and to send the FCM notification to the agents. Basically, Firebase, it is storing in a real time, and we are sending a location to the like agents in a real time. There are delivery application and as well as the agents through that delivery app. We are sending location to the agents. Agent, they can able to track the our now the where is the product is, and they can intimate to the they can call to the particular resident, so they can have available in a home, they can receive the product. For that we are using a Firebase RTDB. And offline, actually Firebase it's support for offline. In case if there is no internet connectivity, it will store in a cache, and again it will support for up to 10 MB of the space. In case if it is crosses 10 MB, then it the data which is not synced to the Firebase, that data it will clear, and it will free up some space, and it is not relevant like in case for that we need to set some set persistent enable true in a code to enable offline kind of a thing. But even after that, in case app restarts, in some cases, there is a chances to miss the data. For that, we need to handle it manually to checking the connectivity. There is a different kind of a listeners will be there. Through that listeners, we can check whether it is in a connective state or a disconnect state. If it is a disconnected, get the data and store it in somewhere, and after connecting back, we can push that data to the Firebase RTDB. That is architecture we are doing it, and accessible to the different clients, different devices. Actually, we can access it from the web, and we can access from the different Android applications from real-time basis, and we can do the operations and based on that, and we can set some set of rules, and a read or write set of rules. We can set it in a Firebase or TDB. Yeah, Firebase Analytics. Actually, Firebase Analytics, Engage, and Crashlytics we are using in our application. Real-time application means we can check the app where it is using, which countries and how many users are using it. Those kind of a real-time analytics we can check it in a Firebase. And event. Actually, there is a default of events. It is already providing from Firebase. We are using some custom event, like how much profiling it is happened through the agent in a particular agent, and the insurance it is happened, and how does it is happened, everything we're tracking through the event in a debug view. In case it is in a running in a rural area, in case any device specific issues that is happening through in our app, we are using debug view and we are tracking the issues. And to authenticate the token authentication purpose, we're using the Firebase and Test Lab to test the applications on a different devices and a different configuration. Crashlytics, of course, is the default one. In-app messaging, we are using it for to send a campaign kind of thing in case of any vaccination programs it is happening. So then we are using an app messaging and cloud messaging to check the order statuses, and sending the message notification to the agents. We are using a cloud message. Yeah, this is how actually some screenshot like I prepared for. This is like a campaign. So in case any vaccination program campaign it is happened through the my in-app messaging, we are sending this kind of a messages to the agents so that they can register. And this is like a cloud messaging. We are sending order status in case if it is delivered or rejected or placed. So we are sending these cloud messages. What is actually it is realm is a local DB, so that is how that is what we are in. There is a different kind of a local DBs are there. SQLite is there, SQLite by default. So again, green DB is there, object box is there, and room is there. There are different kind of databases, but we are using that realm. Why? Because this is like very lightweighted data, and again it is combining with the MongoDB Atlas. No need to write any manual kind code to sync the data and fetch the data. Because of that, we are using a rel, and it is available for different languages: Objective C, Java, Kotlin, C Sharp, and JavaScript. Why we are using rel is it is very intuitive to the developer, so it is very less coding. We can create our entity. Through that entity we can directly communicate with the MongoDB Atlas, and no need to create any relational module here. So it is taking care of everything. And why the main purpose is our application it is running in a 100% offline kind of a thing. So here in MongoDB rel, first is offline, then it is syncing back. It is not connecting, checking the any internet connectivity. First it will store the data, again it is pushing that data to the central DB. And build basically it is, especially it is built for a mobile, and it is very lightweight, and it uses very less memory, disk space, and battery life. So and object oriented programming, this is like a score some code snippet. So how to create an object, how to map with the different objects, and how to initiate the realm, and how to get an instat, and how to execute the object. Those kind of how to insert the all the code snippet I did here. And reactive apps, actually it is like, for example, if I updated something in some page, it will automatically reflect in the relevant pages. Of course we can freeze that element also. For that, this is the code snippet, and it is fully encrypted. Basically, we are collecting the health related data, so this is very um, like personal kind of a thing. So we need to encrypt the data. So this is by default it is providing the encryption method here. So we need to just enable the with the encryption key. If we make it encryption as enabled, then we can't able to hack the data from the local DBs. Yeah, there are many other reasons why we are using run. It is for fast querying. So because it is zero copy architecture module they were implemented, so we can run a complex queries within a microsecond. Transfer from one database we can create, and we can share with the multiple platforms. And it is mainly it is a open source, and it is provided under the license Apache 2.0. Data sync, actually, yeah, it is syncing the data default by the SDKs, or no manual code it is required in a data sync model. This is our realm sync it is works. So first It is synchronizing the data between the clients and the Mongoose, and it enable the offline first. So first it is storing the offline, again it is pushed back to the central DB when network is available. So conflict resolution, there is a one challenge in a realm sync is, for example, which data, because multiple of agents are working in the same object, how to resolve the conflict. So here there is a set of rules in a conflict resolution. They were using operation transformation algorithm to resolve this issue. So by default, delete as a primary, the first priority rule. So if the delete option is there, then that object will be deleted. And second, it is sorting on the based on the updated time. So which is the latest one, that data it is writing to the DB. So those kind of a conflict resolution architecture it is using. Yeah, and as I put, there is no manual code required to push and pull the data. So client SDK is handling the data. Yeah. Yeah, this is how actually this is a central DB, the MongoDB realm, and we are working with a different OSs like Android, iOS, and the realm it is working as a middleware, and it is pulling the data from the applications and it pushing back to the admins. Yeah, combinedly MongoDB realm. See, before MongoDB realm, we need to create a different endpoint to get a data and push back. Now MongoDB realm. So through this MongoDB realm, the SDK itself handles everything. So these are like some references I used to create this. Yeah. So this is
Okay,
about
thank you
my
so
session.
yes, yeah, thank you so much, Anil, for sharing. You're very generous to actually share all this information with us. Yeah, and personally, I really like what you and your team is doing. I think there are still a lot of people in this world that really need our help, and I think in the rural area they really don't have the connection. So and then your team is actually doing something to help them. I really really like the mission. Yeah. So and for those who would like to know more about Reach 52, right? And what Anil has presented, maybe he has gone a little bit fast because we ran out of time. You can actually go to our website, right? And then we will actually be posting his slides on the website, and then so that you can actually click, and then you can go to his LinkedIn profile, and you have any questions regarding this MongoDB and how he used Firebase, you can actually connect with him. Yeah. Okay. So yeah. So now let's Q&A question. So Anil, because of time running up, so we have actually one question for you. So let me put the question up. Okay, so did you and your team have to migrate from using a different store to Realm? And how long did the effect take? And what was the last tool used?
Actually, we are not used any tool to migrate our data from the previous. Basically, previously we are using our own database, local DB, not a root previous marketplace application. So here we are using a rel. So to that, we are using Python script to migrate all the data, because in a new application we use the different architecture and the data structure. So to map that, there is no default tool to map with our data structure. Because of that, we use my Python script. So the script we migrated the data.
Okay, okay. So thank you for your answer. Okay. So for those who wants to know more, you can actually link up with Anil, and then probably you can actually he can actually share more with you. Yeah. So
Sure.
thank you so much, Anil, for the time and your presentation. Thank you for being generous with the
Thank you.
information. Yeah. Okay, I'll
Yeah.
remove you from the stage.
Sure. Sure.
Okay. So once again, thank you, Ashik, Wei Ching, and Anil, for sharing your health tech projects with our community. And thank you everyone for joining our Lakopi today. Yeah, so if you like to rewatch the session, we can always check it out on our Facebook page and our YouTube channels. The speaker presentation slides, like I mentioned earlier, will be available on our website over the next couple of days. Yeah, if you like our content, please stay connected with us by signing up on our mailing list on our website, or follow us on our social media channels. Yeah. And lastly, we want to hear your feedback. about this event, you can actually provide us with your email address to stand a chance to win some gifts. We'll be selecting 5 lucky winners. So remember to check your inbox later this week. Meanwhile, stay tuned for our upcoming events on our website and social channels. We look forward to seeing you again. Okay, thank you so much for your time, and goodbye.